Welcome back, everybody. In this video, we're going to be talking about how to simplify rational expressions. Let's get started. Well, what do I mean by a rational expression? A rational expression has the form polynomial over another polynomial. And to show you how to simplify these, I'm going to take a bit of a different approach this time. So let me know in the comments how you feel about this setup as opposed to what we've seen before. The difference here being I've gone through and worked out all of our examples, and I'm going to sort of talk about them as they come up. In part A of this first example, I'm asking you to simplify x cubed plus x squared over x plus 1. A good strategy is to start by factoring out the numerators and denominators fully before you get started, because you may be able to make your problem easier. Notice in the numerator of part A, I've got a common factor of x squared, and after I pull it out, it reveals a factor of x plus 1 that I can cancel top and bottom, leaving me with x squared only. In part B, something similar happens, but this time I've got to factor both the numerator and the denominator. In the numerator, I get x plus 5 times x plus 1. In the denominator, I have a difference of squares, x plus 5, x minus 5. And now I have an x plus 5 top and bottom that can cancel. A really common mistake that I see is once you get to this point that I've written in purple, some students may say, oh, I've got an x on the top and the bottom, so let me cancel them. But the mistake here is that those are not factors of x. Those x are part of a factor. Right? I don't have an x floating around out front. The x has the plus 1 or the minus 5 with it. There's sort of an imaginary set of parentheses around those guys. So be careful with that mistake. Let's go on to some more complicated problems. Here, I'm asking you to multiply and divide these rational expressions. So in the first one, part A, we are multiplying two of them together. Again, I have fully factored everything out before I got started. That way, I could cancel all of these factors before I did the multiplication, and that made things a lot easier for me. I just had an x plus 1 left over on top and just had a 3 left over on the bottom. Similar process with part B, but this time I've got division. Remember, with any sort of division, no matter how scary the fractions are, in order to divide them, I just flip it and multiply. So I'm going to flip that x plus 2 over x minus 2 upside down, and then just multiply them together. From this point, I've only got one thing to simplify, the numerator on the left-hand side, which is a difference of squares. So I simplified that into x plus 2 and x minus 2. Then I had a factor of x plus 2 that canceled top and bottom, leaving me with two factors of x minus 2 on top and one factor of x on the bottom. We're going to skip over part C for now. In part D, here I am asking you to add two rational exponents together. Luckily, these two have the same denominator, so I can just add their numerators, and I end up with an extra factor of 6x plus 5 in the top when I'm done with that, so I cancel them top and bottom, and all I'm left with is a 2. So 2 is the final answer. But in part E, I don't have that luxury of having the same denominator, so I have to get a common denominator. I did that by multiplying top and bottom by x, and now that they have the same denominator, I can add their numerators together, and I have no more simplification to do. 5 plus 3x all over x is the final answer. Part F is similar. Here, I need a common denominator. I notice that both of them have a 3, but the right one's missing an x. So I multiply top and bottom by x. That let me get a common denominator and just subtract their numerators normally, leaving me with 10 minus 8x on top and 3x on the bottom. Part G took a little bit more work because I'm a little further away from having a common denominator. I noticed that my right one has an 8. My right one is missing a factor of 6, and my left one is missing both a factor of 8 and x. So I had to multiply my left fraction top and bottom by 8x, and my right fraction top and bottom by 6. That left me with 40x over 48x squared plus 6 times x minus 3 over 48x squared. Now that I have a common denominator, I can add their numerators normally. After a bit more algebra, I'm left over with 23x minus 9 all over 24x squared as the final answer. In part H, I've got even more work to do because now I've got some polynomials in the denominator and I have to multiply them top and bottom on the opposite side so that I get a common denominator of 3x plus 6 times 2x plus 4. After quite a bit of simplification, I'm left over with 13 over 3 times 2x plus 4. That's the final answer. In part I had a similar trick, but my denominator on the left, when I factor it, actually reveals to just be the right denominator squared. So I just needed to add an extra factor of x plus 3, or sorry, multiply an extra factor of x plus 3, top and bottom on the right-hand side, and that made getting a common denominator a little bit more straightforward. In the end, 4 times x plus 4, all over x plus 3 squared, is the fully simplified answer. Now, you may see these kinds of expressions called complex fractions, because I've got fractions of fractions. I personally don't like the name complex fractions because it makes it sound like it's a fraction of complex numbers, but some books, including our own, call them that. Remember, fractions are just division, and we don't have to be scared of them. The first thing I did was fully simplify that numerator because it was not simplified. I got a common denominator, combined them, and fully simplified the numerator. Then I worried about the big fraction bar. Remember that just means division. So I'm taking my numerator, which is x minus 3 over 3, and dividing it by my denominator, which is x minus 3 over 1. To divide fractions, I flip and multiply, and all I'm left over with is a third. Same thing in part L. Oh, I think my lettering is off there. I missed J. Sorry, J. I have 1 minus 1 over x all over xy. So what I did first was fully simplify my numerator, and then I combined my like terms and simplified again. Right? Now I have my numerator, x minus 1 over x, divided by my denominator, xy. So, to divide by a fraction, I flip and multiply. I had no factors to cross cancel here, so I was just left with x minus y over x minus 1 over x squared y throughout the course of the video. And I'm curious to see how you guys prefer this content to be delivered. Let me know in the comments. But thank you all for watching, and I'll catch y'all in the next one.